Welcome back to my channel. I am Anshul from Quantshala. So today we will discuss the solutions to the factors quiz that we recently conducted on our Facebook group. Lot of excited and enthusiastic aspirants. Always a pleasure to see excited students. Also, we had a great response on the engagement session yesterday, which was a session on preparation guidance and strategy. A lot of aspirants drew huge benefit out of it. So we'll talk more about that in the end. Let's get started with the quiz solutions. So the quiz had 5 questions to be completed in 20 minutes. 20 minutes was a very good time to be completed for these 5 questions because most of these questions are easy to medium, only 1 or 2 were tricky. So let's get started with the first question. This says how many factors of this number are perfect squares. So we have discussed such similar questions in the past videos where we've discussed the factors concept. So if you haven't watched those or if you are unfamiliar with those basic concepts, make sure that you watch those videos first. So the first and foremost thing for factors question, we'll try to factorize this number 1 to 3, 1 to 3. So one mistake that aspirants make here is they try to factor this conventionally, dividing by 3 first, then trying to again divide by 3. That is a slow approach. In this we see that there is a pattern 1, 2, 3, 1, 2, 3. So let's try to break this down into easy numbers. So 1, 2, 3, 1, 2, 3. This can also be written as 123 multiplied by 1000 plus 123, right? Again, this will give you the same result as on the left hand side. So you can say, take 123 common from here, this will become 123 into 1001. Now factorize these separately, it becomes very easy. So 123 is 3 into 41, multiplied by 1001 is 7 multiplied by 11 multiplied by 13. So this is the prime factorization for the given number. Okay. Now for perfect squares, we know that each of the power has to be even, because what are perfect squares? A perfect, let's say a natural number. Any natural number will have a prime factorization of something like this, p raised to power x, q raised to power y. This is any general natural number. The square of this will have p raised to power 2x and q raised to power 2y, which means the exponents for any perfect square are always even. In this, it is not possible to have any even exponents unless all of these are 0. So the only option for the factors of this for it to be a perfect square is 1, where the exponents of all of these are 0. Even if one of these is 1 instead of 0, that becomes a non-perfect square. So the answer for this question will be simply 1. 1 is not an option, so the answer is none of the above. Very simple question to solve. Just make sure that you know how to factorize this fast, because if you factorize this the conventional way, you'll take an extra 10 to 15 or 20 seconds. This way you can factorize it within 3 or 4 seconds. Coming to the next question. So this says A, B, C and D are 4 numbers which have these many factors respectively. How many of these numbers can be perfect cubes? Okay, so this sounds very similar to the previous question, but understand the difference. There is a slight difference. Earlier we were talking about, so in the previous question we were talking about how many factors of this number are perfect squares. Okay, so this is the original number, how many factors are perfect square. Whereas here the original numbers are A, B, C and D. And we're talking about how many of those are perfect cubes. So we have the number of factors this time, but we want to see how many of the original numbers can be perfect cubes. Okay. So solving similarly, any general natural number can be written of this form: p raised to power q raised, p raised to power x, q raised to power y, or any number of prime factors. Okay. And the cube of that will be p raised to power 3x, q raised to power 3y. This is a perfect cube, which means all the exponents have to be multiples of 3. Okay. So a few perfect cubes, what could they be? 2 raised to power 3 or 2 raised to power 3 into 3 raised to power 3, or let's say 2 raised to power 3 into 3 raised to power 6 as well, because it does not have to be equal to 3, it can be a multiple of 3 also. So 2 raised to power 3 into 3 raised to power 6 multiplied by 5 raised to power 9 also is an option. Okay. So what are the number of factors of this one? This will be 4, 1 plus 3. This will be 4 multiplied by 4, 16, and this will be 4 multiplied by 7 multiplied by 10. I'll not solve this. Okay, so each of these, as we see, the powers have to be multiples of 3. That means the numbers that we multiply for calculating the number of factors will be 4, 7, 10, 13, numbers of this sort. If you didn't understand this, pause the video here, spend some time with your pen and paper and try to figure out this. Okay. So now we are given the number of factors are 28, 64, 112 and 343. How many of these can be perfect cubes? Okay. So A has 28 factors. 28 could be written as 2 multiplied by 14, which means the prime factorization could be p raised to power 1 multiplied by q raised to power 13. How many factors will this have? 2 multiplied by 14, 28. Is this a perfect cube? No. But is this the only configuration that a number with 28 factors can have? It can have 4 into 7, right? I didn't write 4 into 7 here, but it can have 28 can be written as 4 into 7, which means p cube into q raised to power 6. A prime factor of a number which has prime factorization equal to this or similar to this will have 4 multiplied by 7 equal to 28 factors, and this is the perfect cube. So as I was saying, any number, basically if the number of factors can be written as multiples of 4, 7, 10, 13, then that can be expressed as the perfect cube. So 28 is 4 into 7, perfect cube. Okay, so 28 can be a perfect cube. So basically A can be a perfect cube. For 64, 64 is 8 multiplied by 8, or also 4 multiplied by 4 multiplied by 4. Basically the prime factorization could be p cube, q cube, r cube. This is a perfect cube. So 64 also, basically B also can be a perfect cube. Similarly 112 is 16 multiplied by 7, which means 4 into 4 into 7. Again this would be p cube, r cube, p cube, q cube, r raised to power 6, which can also be a perfect cube. So C is also a perfect cube. C can also be a perfect cube. It doesn't necessarily need to be a perfect cube, it can be a perfect cube. For D, 343, 343, all of us know is 7 cube, 7 multiplied by 7 multiplied by 7. So again, this can be, D can be a perfect cube because the number of factors can be represented in this way. Okay, so the answer in this case will be A, B, C and D. All of them can be perfect cubes, so the answer is 4. Okay. Many aspirants make this mistake that if they can't solve it, they'll just mark the answer as cannot be determined, because this mostly occurs when the answer is actually this. So don't make this mistake. Make sure that when you're doing this, there is a 50% or more risk that you might get a -1 marks instead of 3 marks. So do this knowing that you are taking that risk. Coming to the next question. So this says S is the set of number of factors for all 2-digit numbers. One thing many aspirants get scared by seeing this word set, the minimum and maximum values in S. So they leave this question just by seeing set. Make sure that you don't do this, because set will be used in a lot of questions where set is not actually required, it's just a terminology, as we'll see in this question. So S is a set of number of factors for all 2-digit numbers. What are all 2-digit numbers? From 11 to 99. S is a set of number of factors of these numbers. So let's say 11, how many factors? 2 factors. And there are so many factors, right? Some other number might have 3 factors, some number might have 4 factors, and so on. So S is this set. So S is this set which tells you the number of factors that a 2-digit number can have. P and 2Q are the minimum and maximum values in S. What is the sum of factors of this? So entirely this consists of 3 questions. First, find the values of P and Q. Minimum and maximum values in S. This is the first question. Finding P and Q. Second, finding P raised to power Q minus Q raised to power P. This is going to be very easy. This is just calculation once you find P and Q. Third, finding the sum of factors. So don't solve the questions in a rush and forget to solve any one of these steps. Some of the people, what they'll do is they'll calculate this P raised to power Q minus Q raised to power B. They'll try to find it in options. If it is there, they'll just mark that. They won't bother to calculate some of the factors. Okay, so calculating P and Q. P and 2Q are the minimum and maximum values in S. That means in this set, okay, which consists of the number of factors a 2-digit number can have. So what is the minimum number of factors a 2-digit number can have? Can it have 0 factors? Can it have 1 factors? Can it have 2 factors? 2 we just saw, 11 has 2 factors, 1 and 11. So each prime number has 2 factors, itself and 1. Any number cannot have less than this number of factors, less than 2 factors. So straight away we know that P. So P is going to be 2. We still need to find the value of Q. Okay. So maximum values in S. That means the maximum number of factors that 2-digit number can have. Some people, what they'll do is they'll calculate 99. They'll see 99. 99 is the largest 2-digit number. How many factors does this have? 3 multiplied by 3 multiplied by 11. So this is 3 square into 11. 3 into 2 equal to 6 factors. Okay. So Q is 6? No. Or 2Q is 6? No. Because 99 being the largest two-digit number doesn't mean that it will have the largest number of factors. So let's again see how do we calculate the number of factors to essentially find the value of q. So if a number is of this form, p raised to power x, q raised to power y, r raised to power z, where all p, q and r are prime numbers, what is the number of factors that we studied in the last video? 1 plus x, 1 plus y, 1 plus z. Okay. Make sure you don't just cram this formula, you also know how this works, why this works. Okay. So the exponents, we are adding 1 and multiplying all of them. And we want to find the maximum number, maximum value for this for any two-digit number. Okay. So essentially, how we'll increase the value of this? By adding more terms here or by increasing the individual values of x, y and z. What will help more? If you increase the value of x by 1 or you add one more term here, obviously adding one more term here, because essentially in that case you will be adding 1 plus 1, you will be multiplying this number by 2, and in the other case you will only be adding 1 here, so adding 1 to an already existing multiple. So let's try to have as many terms as possible. Okay, so let's take the minimum prime numbers, because we want to have as many prime numbers possible but still have the resultant as 2-digit. Okay, so 2 multiplied by 3 multiplied by 5, these are the 3 smallest prime numbers. This gives us the result of 30. Can we also have 7 here? No, that will go 210. So the maximum number that we have got till now is 30. Now we'll look at increasing the powers, because we can't add one more number here. So essentially let's add one more power here, 2 square 3 5. This becomes 60, still under 100, or still basically a 2-digit number. If you add one more here, make this 2 cube, then it would become 240, I think, right? Or no, 120. It would become 120, non-2-digit number. So we'll have to stick to 2 here at max. So what is the number of factors in this case? 3 multiplied by 2 multiplied by 2 is equal to 12. Okay. So this is one option. Let's also look at other options. So this is the one way that we could increase the number of values present. Let's also see what happens if we try to increase the individual values of x and y, or try to strike a balance. So if you try to increase the individual value while you don't care about the number of multiplicants that you have here, so in that case you will have only 2 raised to power 6. Okay, so 1 plus x would be 7 in this case. So 2 raised to power 6 is 64, while 2 raised to power 7 will become 128. So this case you will have 7 factors. 12 is still winner in this case. Let's try to strike a balance now. So let's have something like let's say 2 cube. Okay, 2 cube is 8. Still you can multiply 3 here to get 24. Still you can multiply 5 here. No, you can't multiply 5 here. But can you multiply 3 square here? Yes, you can do that. Because 8 multiplied by 9 is 72. How many factors does this have? 4 multiplied by 3, again 12. You can try a few other numbers, but this is mostly I've covered all the cases. So we know that the maximum value in S, or the maximum number of factors that a 2-digit number can have, will be 12. Okay. So Q is 12? No. 2Q is 12. That means Q is 6. So P is 2, Q is 6. Okay. Now calculating P raised to power Q minus Q raised to power P. Okay. Let me scroll down here. So P raised to power Q minus Q raised to power P. P is 2, Q is 6. 2 raised to power 6 minus 6 raised to power 2. 64 minus 36. 28. You should know how to do fast calculations, because that helps you greatly in the exam. Don't use the on-screen calculator if the calculation is not very complicated, because you will waste some precious seconds on the on-screen calculator, because you can't use the keyboard there. You have to take your mouse pressed on each of those buttons. So I also made a video on fast calculations. Make sure to watch that. I'll be uploading more videos there. So 28 is P raised to power Q minus Q raised to power P. Is 28 the answer? No. We are supposed to find the number, sum of factors of this one. So 28, again, writing the prime factorization for that one. That is 2 square into 7. Is that correct? 4 into 7, 28, right? In the previous video, we also discussed how to calculate the sum of factors. I'll just use the formula straight away here. So we are adding all the exponent values from 0 to 2 and 0 to 1 in this case. So this gives us 7 multiplied by 8 is equal to 56. What is the answer? Is 56 an option? Yes, 56 is an option. So the answer is 56 in this case. So coming to the next question, n raised to power n is 10 raised to power 5 lakhs. This question is very similar to a CAT 2018 or CAT 2017 question. CAT had a very similar question to this one. This is a slight variation. If S is the set of number of factors, again set, you don't have to scare of the word set. If S is the set of number of factors for all possible values of n, what is the sum of all values in S? It does, the only thing it means is, let's say n has some possible values. Just taking example, 2, 3, 4. These are, let's say, the possible values for n. So S is the set of number of factors for all possible values of n. What does that mean? So 2, 3 and 4 are possible values of n. Just taking an example, they won't satisfy in this case. What are the number of factors of each of these? 2 has 2 factors, 3 has 2 factors, 4 has 3 factors. So this will become your S in this case. So what is the sum of all values in S? So the answer will be 2 plus 2 plus 3. Okay. This is what the question essentially means. Now we are supposed to find this list of n. What is the possible values of n actually? Okay. So I'll remove this because this is not relevant to the question. This is just explaining what the question means. So now we know that n raised to power n is equal to 10 raised to power 5 lakhs. Okay, I won't write this 5 zeros at a time. I'll just write 5L here. This means 5 lakhs, 5 and then 5 zeros after that. These are 5 zeros, right? 1, 2, 3, 4, 5. Yes, 5 zeros. So first of all, we see that this 10 is not a prime number. So let's try to write that as prime factorization. That means 2 raised to power 5 lakhs into 5 raised to power 5 lakhs. This is n raised to power n. Okay. So on the right hand side, we can see the powers of 2 and 5 are equal. So that means in n also they have to be equal. So n can be 10, n can be 100, but can n be 20? Because 20 is 2 square into 5. If you raise this to n, then the powers of 2 and 5 will become unequal, which won't satisfy the RHS. So that means n has to contain equal powers of 2 and 5. That means something of the sort 2 raised to power x into 5 raised to power x. Okay. Or essentially it becomes 10 raised to power x. Okay. You can also compute this manually just by looking at the question. This is because I'm explaining it to you in detail. Otherwise, this thing you can derive within seconds, that n has to be of the form 10 raised to power x. Okay. So let's put n is equal to 10 raised to power x. What does the LHS become? 10 raised to power x raised to power 10 raised to power x is equal to this thing. Can you simplify this? Very basic exponent properties. You should know this. If you don't, please go to the NCRTs or go to some basic videos where you understand this. X into 10 raised to power x. This becomes 10 raised to power x, 10 raised to power x, essentially the same thing. And this is equal to 2, because we have 10 on the LHS, we also write 10 on the RHS also. So this becomes 10 raised to power 5 lakhs. We'll again switch back to the original thing given in the question. So 10 and 10, we can equate the powers. X into 10 raised to power x is equal to 5 lakhs. X into 10 raised to power x is equal to 5 lakhs. 5 into 10 raised to power 5. Okay. Now, easily, first thing is you can easily find that x is equal to 5 just by looking at it. Or if you're not writing like this, if you're just writing as 5 lakhs, what you can also see is that it becomes 5 multiplied by 1 lakh. Okay. Correct number of zeros. So this 1 lakh again is a power of 10. That means equal number of 2's and 5's, or equal powers of 2's and 5's. Similar is the case is for this. So that means x has to be equal to 5, or x has to be a multiple of 5, because there is an extra 5 here. So that 5 has to go to x. Okay. So let's try by putting x as 5. Does that satisfy? 5 multiplied by 10 raised to power 5, 5 lakhs. That satisfies. So we know that x is equal to 5 in this case. Okay. Try putting back in the equation yourself and see if that satisfies. So x is 5. That means n is 10 raised to power x is equal to 10 raised to power 5 or 1 lakh. Okay. We were looking at what all possible values are there for n. N has only one possible value, 10 raised to power 5. There is no other possible value. So S is the set of number of factors for values of n. So how many values does 10 raised to power 5 have? How many factors does this number have? This is 2 raised to power 5 into 10 raised to power 5. 5 raised to power 5. 2 raised to power 5 into 5 raised to power 5. Number of factors is 6 into 6, 36. So S is only 36. Sum of all values inside S is also 36. So the answer will be 36C in this case. Okay. I think we have solved 4 questions, only the last one is left. This is a tricky question. Good question for concepts. So n is equal to this number. P is the number of factors of n square which are less than n and are not a factor of n. Okay. So three or 4 pieces of information given. Let's try to compile that in one pictorial diagram. So n is equal to this. Let's not consider this right now. Okay. P is the number of factors of n square which are less than n. Okay, so let's draw a number line here. Very bad number line. Okay. So we'll have 1 here n somewhere here, and n square will be greater than n. Okay. I drew this extra square here. So n here and n square will be here. Okay, n will be somewhere in the middle, not exactly middle, but somewhere in between. Okay, so let's look at how many factors of n square which are less than n. So they're asking for factors of n square which are less than n, coming till here, not equivalent to n, and not a factor of n. That means not a factor of n. Okay, so first task is to find how many factors of n square exist here in this space. Okay, let that be x. Then if we find how many factors of n exist in this space, if that is y, if we subtract that, does this give us the answer? Let's take an example. So I'll also try to take an example on the spot. Let's say n is 6. Okay, n square will be 36, and this one is here. How many factors does 36 have before 6? It has 1, it has 2, it has 3, it has 4. Okay, it doesn't have 5, and we are talking about less than 6. How many factors does 6 have? So first let's look at the number. X in this case is 4. And how many factors does 6 have before 6? Only 3. 1, 2 and 3. Okay, 3. So x minus y gives us 1. And essentially, indeed 4 is the only factor of 36 which is below 6 and not a factor of 6. Okay, so we have broken down the question into two parts, calculating x and y. What is x? I'll write this in detail. So we have to support number of factors of n square which are less than n minus number of factors of n which are less than n. Okay, so now this is an easy job. Number of factors of n we know how to calculate. N will be a factor, we subtract 1 from that, we get this value. Okay, let's look at how. The given number is 1, 2, 3, 6, 6, 0. Okay, either you can try to factorize this the normal way, or again you can try to employ some kind of trick which you can also use in other questions. So in this case you can also do a conventional prime factorization, but I'll again go with the shortcut approach. So 12 and then 4 zeros after that, plus 36, 2 zeros after that, plus 60. 12 is common. So you get 10,000. So this is only possible because all of these two digits are factors of 12. 12 into 10,000 plus 300 plus 5. Okay. So this becomes 12 multiplied by 10,305. Okay. So 12 multiplied by, divide this by 5 because you this is divisible by 5. You divide this by 5, you get 2, 2, then you get 6, 1 if I'm not wrong. Right? So you divide by 2, you're dividing by 5. Right? This is 10305. Oh, I think I made a mistake here. So 10,305 you divide by 5, you get 2 first, then you're left with 3, so you have write a 0, then you get 6, and then you get 1, so 2061. Okay, now try to factorize this. This is divisible by 9 clearly, so this becomes 9 multiplied by, divide this by 9, you get 2, then you get 2, and then you get 9. 229 is not divisible by any prime number that I can think of. How do you find if the number is prime or not? You calculate, or you try to divide this by prime numbers less than root of this number. What is the ballpark root of this number? Consider one above this. So 256 is perfect square, right? So 16. So see all the prime numbers between 1 and 16. If you can divide 229 by any of those, only the prime numbers, which will be handful, 6 or 7 or 8. Right? If you can divide, fine. Otherwise, this is a prime number. So what is the prime factorization of the given number? 12 is 2 square into 3. So we get 2 square, 3, and this is 3 square. So we get 3 cube. We get 5 raised to power 1, and then we get 229. Okay, this is the prime factorization of the given number. 2 square, 3 cube, 5, 229 raised to power 1. What is the number of factors of this? We have 3 multiplied by 4 multiplied by 2 multiplied by 2. Basic formula. 3 multiplied by 4, 12 multiplied by 4, 48. 48 is the number of factors. So y is 48. By y I mean the second term, not 48, because this 48 includes the number itself, this number itself. We are looking for factors which are less than n. So this value becomes 47 in this case. Okay. Let's come to a blank page. I'll write this prime factorization down again. 2 square, 3 cube, 5, 229. So the prime factorization is 2 square, 3 cube, 5, 229. We're supposed to calculate x minus y. Now you know what the definition of x and y are. And we have calculated that y is equal to 48 minus 1 equal to 47. The challenging job now is to calculate the value of x. Okay, what is x? I'll write that down again for you. Number of factors of n square which are less than n. Let's draw the number line again. Okay, you have 1 here, n square here, and n somewhere here. Okay, what are the factors of n square? Is 1 a factor of n square? Yes. How do you get n square? 1 multiplied by n square. You get this. Let's say n square is an even number for now. So you will have n square by 2 here, you will have 2 here. Okay. So multiplying 2 and n square by 2, you will get n square again. So a similar pattern follows. So whenever you increase the number here, this number has to decrease, right? By basic multiplication laws also. So this is this kind of pattern that you get for factors of n, for any number in fact. Okay. And because n square is a perfect square, it is also obtained when you multiply n by itself. Okay. So this is the kind of pattern that we see. For every factor that is on the right of n, you have a factor that is on the left of n. Okay, for example, consider this. If there is factor here, y, which is a factor of n square, there has to be an x here, which is less than n, and you multiply x and y to get n square. So for every factor on the left, you have a factor on the right. Okay. Another very interesting property to show from here. Okay. In the last video we discussed, and even you can find that out right now, that any perfect square will always have odd number of factors. We can clearly see that from here also. So all of these are pairs, all of these lines that I have drawn, and there is one of these n which is alone, which is not a pair. So n multiplied by itself. So you're multiplying two numbers, but that is essentially one distinct number, right? So the number of factors of n square will be odd, you can see, okay? All of these pairs, which means 2 multiplied by something, and then this n separately. So n square is odd number of factors. You can verify that by the formula as well. Okay, so now let's say n square has f factors. Okay, n square has f factors. How do you calculate this number of factors of n square less than n? Easy to calculate now. Subtract 1 first. So you subtract this n thing. Now you are left with only pairs. If you divide that by 2, you get number of factors of n square which are on the left side. Okay, we can calculate f easily. The prime factorization of the given n is this. What is the prime factorization of n square? Squaring this, 2 raised to power 4, 3 raised to power 6, 5 raised to power 2, 229 raised to power 2. Number of factors of this, easy to calculate again by the same formula. 5 multiplied by 7 multiplied by 3 multiplied by 3. 35 into 9, 315. Okay, again, fast calculation is very important for CAT. Spend 15, 20 or half minutes or half an hour daily to improve your calculation skills. Okay, so this is what you are getting as f. Minus 1 by 2, you get 314 by 2, 157. Okay, so x becomes 157. So now x is 157. As we calculated on the last slide, or we've written here also, y is 47. Subtract these to get 90. 110. I'm talking about fast calculations, but making calculation mistakes in the video itself. So 157 minus 47 becomes 110, which is your answer. Do we have an option for 110? No. Oh, the question is find the sum of digits of p. So these are very classic mistakes. So if there was an option to 110 here, I would have gone ahead and marked that 110. Okay, because there is not an option here. So I saw what is the actual question. So always make sure to read the entire question. Sum of digits of p, so 110. Sum of digits of this is 2. So answer is 2. Okay. This is a slightly tricky question, I know. Spend some time with it, play around with it, take some values, take some example values like I took for 6 and 36. Take some more example values, spend some more time with it, you will understand this question. So this is mostly it about the quiz questions. I hope you understood each of the questions in detail. If you haven't, pause the video where you are getting stuck and then try that yourself. You will definitely understand it. So coming to the topic which I touched upon in the starting, the preparation strategy and preparation doubt session that we had yesterday. Amazing response and very enthusiastic aspirants, right? So the session was amazing. Many students asked their doubts regarding preparation strategies, how to attempt mocks or increase their speeds. A lot of them hugely benefited from this. Many of them also contacted me personally after the session for more tips and mentorship. So this Facebook platform, basically, this Facebook group that we have is an amazing platform for each of you to connect with me personally and get your doubts clarified each and every day. I'll be there to clarify all your doubts from questions to concepts and to preparation strategies. So I can also talk to you personally if you join there. If you can personally message me, I can answer each one of you in some time. So this will act as an amazing platform for you to get your doubts clarified very quickly by a mentor. So this is mostly it about the factors quiz and the engagement sessions. If you like the video, press the like button, subscribe the channel for all upcoming videos. Share this video with all your aspirants or aspirant friends. All the best, keep learning.